All right, I think we're recording for Addison, and we are starting notes for 1-7. Here's the homework. If you need to pause, go for it. But we're doing a lot of stuff at the beginning that you guys are going to know how to do. So I'm going to kind of go through that maybe a little bit faster, and then some of the other stuff we're going to slow way down because you're not going to know what you're doing, okay? So first of all, this is the first half, analyzing graphs of functions. We're going to talk about symmetry and all of the things, okay? All right, so here we go. Testing for symmetry. Shh. Listen. Okay, we've got a couple different types of symmetry. There's 3 of them. They have x-axis symmetry, y-axis symmetry, and origin symmetry. So they have like this going on here. This is like a reflection in a bird across the x-axis. That's x-axis symmetry. Same left and right with the dog. That is y-axis symmetry. And this one has symmetry with respect to the origin. So it's like what is here is now here. It's also called rotational symmetry. So that's like if you rotate it 180 degrees, it would have like y-axis symmetry or origin symmetry. I mean, okay. So what is in the first quadrant is in the third quadrant. What's in the second quadrant is also in the fourth quadrant. That is
a circle.
That is origin symmetry. Got it? Yep. X-axis, y-axis, origin. Got it. Okay, here we go. Here's another thing that's x-axis. This is the graph of what equation? Do you know? Nope. X equals y squared, or y squared equals x. Yep. Okay. That is that. Do you know what this one is? The one in the middle that has y-axis symmetry.
1, 2, 3.
X to the fourth.
Y equals x to the fourth power. That's like that W thing, right? Okay. And then this one, origin symmetry. Do you know what this one is?
Sine. X to the third. No, it's not.
It does look like sine of x. Yes, it does. I bet it is actually. I bet it's the graph of sine of x. Y equals sine of x, which we don't know what that looks like yet. Yeah. He also does. He does look like if this would continue going this way, then what would that be?
X to the third.
Negative x to the third power. You're right. Right. Okay.
If he oscillates.
But yeah, so he does look like he's going to start oscillating, and that is the graph of y equals sine of x. So if he does this, it depends. If he does that, then that's the sine of x. Whatever. For x cubed, no. Because if you take x cubed and you reflect him across the y-axis, it's the same thing as reflecting him across the x-axis.
Okay.
Yeah. So, good question though. All right, now here we go. Let's talk about. Let's talk about these guys. Okay. Y equals the absolute value of x. This is not graphed, but if you did graph him, do you know what he would look like? He's a V. Like straight in the center, like this. Determine whether the graph is symmetric with respect to the y-axis, x-axis, or origin. Which one? Y-axis. Y-axis symmetry. Okay. B. Ooh, do you know what this one looks like?
Wouldn't it be sideways?
This is a sideways parabola with some -4 due to him.
To the down 4.
You think it makes him down 4, but since it's x equals y squared, the -4 actually moves him to the left 4.
Oh, left.
Yep.
Because it's backwards, because then the parentheses would be up and down.
Right, because it's x equals y squared, so -4 actually means left 4, because in like basically it's as though like this is the top of your graph, right, and this is the bottom of your graph.
Wouldn't it be to the
Okay.
That's x-axis symmetry.
Yeah, so this one has x-axis symmetry. X-axis, because -4 is like down 4, and down 4 in y world is left 4. Okay, so if you would have that in parentheses, like y -4, right, like that would be different. That would actually be up 4.
So if you have like for A, if it's shifted like one left or right, is it still y-axis?
No, if it shifted up or down, it would be. But if it shifted left or right, then it's not.
Then it doesn't have symmetry.
Then it doesn't have any symmetry.
If it was x
Yeah.
minus 2.
So like let's say it's absolute value of x minus 2, sure. That would be shifted 2 to the right, 1, 2, like this. That has no symmetry.
He has no symmetry. 'Cause he doesn't
He has symmetry across the line x equals 2. But he is not x-axis symmetry, y-axis symmetry, or origin symmetry.
So it has to
Correct.
be on, like,
It has to be on, yep. But this one, even though we moved him to the left 4, he still has the x-axis symmetry because that's where the axis lives still. Yes, good question. And there is no C. Okay. Determine whether the graph is symmetric with respect to the x-axis, y-axis, or origin. This is the equation of a circle that's centered at 0, 0, and a radius of 3.
All of the above.
He has all three. He has x-axis, he has y-axis, and he has origin. Now, real quick. This is like one of the only cases, actually I think this is the only case, where he will have all three. Typically if he has x-axis or symmetry, he will not have y-axis, and vice versa.
Probably.
Thank God.
Yes,
Yes, again. Yep, that's for you. You didn't tell me you were leaving. Did you?
No.
Okay.
Where's your mom? What? Aren't you missing enough school?
You're going home?
Oh, getting the football stuff? No. Probably.
Okay. All right. Bye, Brady. Okay. So this is an isolated incident where you have more than one type of symmetry. Typically, if he has x-axis, he won't have y-axis, and vice versa. Right? Okay. All right. So there's that. All right. Now, okay. Let's talk these guys. All right. This example, you're going to be able to do, but example 4, I'm going to teach you some new stuff. All right. So it is considered an even function. Even functions, I think of like y equals x squared. Shh, boys, are you listening?
No.
When I think of even functions, I think of y equals x squared because 2 is an even number, right? Do we know what y equals x squared looks like? He looks like a parabola. So if it is an even function, then that means it has y-axis symmetry because a parabola has y-axis symmetry and he is x to the second power. That's how I remember that, right? Even second power parabola, y-axis symmetry. So if it has y-axis symmetry, it's an even powered function. Yeah?
Oh, okay.
Okay? Odd is like y equals x to the third power. And sometimes y equals x to the third power, I'll make him have extra humps in him, right? Like this. Whoa. Okay? What type of symmetry does this one have?
X.
It is not x.
Origin.
It's like
He has origin. Odd is origin symmetry. Okay?
Oh.
Now, what is, hold on, but what is x-axis symmetry?
Both. Can't be both.
The x.
X-axis symmetry
Doesn't exist.
does not have a special name because why? X-axis symmetry, like this one, does not have a special name because it is
Not a function.
not a function to begin with. So it doesn't have a special name like even or odd, right? So x-axis symmetry is none because he's not even a function. He doesn't pass the vertical line test, right? Okay. So if it's y-axis symmetry, that means it's an even function. If it's origin symmetry, that means it's an odd function, right?
So if it's
Got
not
it?
a function, it's
If it's x-axis symmetry, it's not even a function. What?
What if it's y equals 0? Does that have
This
x-axis
is no
symmetry?
Y equals 0 is a
point, so it can't.
y equals 0 is a line that goes this way. So he would have
X-axis symmetry.
he would have technically both x-axis and y-axis symmetry.
So it does exist.
What?
It does exist.
Yeah. So in very rare circumstances, like that circle one,
You can ask.
that's a rare circumstance where he will have both. That's another circumstance of where he will have both. Yes.
This one.
That one's a function. Y equals 0?
So there's a function that has x-axis symmetry. So you just said that it didn't exist.
Oh, I get ya. Oh, interesting. Yeah. So like x-axis symmetry. Okay, so what he's saying here is like the fact that this has x-axis symmetry, it doesn't pass the vertical line test, it's not a function. But this one also has x-axis symmetry, right? Technically, because he's on the x-axis.
He's on the spectrum.
Interesting. That's a good thought. I didn't even think about that. Okay, that is like the one scenario of when this won't, when I just eat my words just now. Okay, anyway.
Doesn't that also have y?
That also has y-axis symmetry. Yeah. Because if I flip him across the y-axis, if I turn him this way, he'll have symmetry. If I spin him around the x-axis, he will also have symmetry because he stays in the same spot, right? But what he's saying is I said over here, if it has y-axis symmetry, it's none because it's not a function. But this one is because it's like, yeah, interesting. Okay, anyway, all right, there's that. Okay. Number 3, A. Determine whether this thing has x-axis, y-axis, or is even or odd. Let's do x-axis, y-axis origin first, okay? So do we know what this function is called, by the way? This is the cubic root, right? This is the cubic root of x because he goes that way and the other way. Okay. Does he have x-axis, y-axis, or origin? Origin, which means he is
Odd.
odd. That's what they wanted. Odd function. Got it? B. I don't know what this function is called. He's probably like y to the 8th power, or y equals x to the 8th power, or something like that, whatever. Right? He is an even function. He has y-axis symmetry, so he is y-axis, and he is even. He's an even function, yeah?
No symmetry.
Okay, letter C. This was what you were talking about before, where you said if he shifted, he doesn't have symmetry. This one doesn't. So like if he was like this, then he would have y-axis, but the fact that he shifted to the right, this is neither. This is none of the above. Good, good? Okay, now, this is the part that you guys are going to have to listen to. Are you ready?
No.
This is the new part. Okay? You don't know how this works. This is the new part. Okay? Here's what happens. If I give you, well, this will be the last thing that we talk about. We'll talk about piecewise tomorrow, maybe, or something. Okay? So, we need to look at these functions and we need to figure out whether they're even, odd, or neither. Now, I told you that odd, like, was typical of like y equals x to the third, right? But does every x to the third powered function make it odd? For example, like if I take that x to the third power and I move him to the right, now is he, does he have origin symmetry now? No. So not every x to the third powered function is going to be odd, true? Same thing with every x to the second powered function, or an even powered function is going to be even, right?
Yeah.
So how do you know without graphing? Here's how you know. Are you ready?
Born ready.
Okay. If it is an odd, or let's start with even powered function. If it is an even powered function, then it has y-axis symmetry. Write this off to the side. Okay?
I did that.
Y-axis symmetry. All right. If two things are even, or if a function is even, what you can do is you can replace the y coordinate with a negative, and it stays the same as the x and y originally. Let me show you what I mean by that, okay? I know that y equals x squared. No. I read that wrong. Blip, 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 blip. The negative goes on the x. I'm sorry. I read that wrong. Negative x comma y. There you go. Okay?
I can only see.
All right, so I can replace it with negative x and positive y, and it will end up being the same. For example, the y is going to stay as just y. The x is going to become negative x, right? So when I do that, and I take negative x and I square it, what happens when I take negative x and I square it? The negative is going to become positive, so that just becomes y equals x squared, right? It is the same as what it was originally, right? So if I plug a negative in for x, it ends up returning back to its normal form. That means that has y-axis symmetry. That means it's an even function, right? Okay? It is an odd function if I look at the equation and it has origin symmetry, or in other words, if I take negative x and negative y and plug them in and it returns back to xy, okay? So if I can replace them and they both will be the same. Now let me show you, we know that the function y equals x to the third power, that is an origin symmetry, okay? Are you watching this? Yep. Because if I take the y and plug in negative for the y, and I take the x and plug negative in for the x, right? Okay, this one's a little tricky. If I take negative x and I cube it, it stays negative x cubed. This y stays negative y. How did that return back to the original? Oh, but if I divide both of them by a negative 1, right, then it will be y equals x cubed. So it did, in fact, turn back into its original form. So when I plug a negative in for both of them, then it has origin symmetry. Now, you can also do the x-axis symmetry, right, but he doesn't have a special name. If I want to test for x-axis symmetry, I'm going to plug in x negative y, and he will return. He will be the same as xy, right? X comma y. We know that x equals y squared has x-axis symmetry.
I can't write it anymore.
Okay, so if you don't want to write this down, you don't have to, because this one doesn't have a special name, right? But it has x-axis symmetry. If we plug in a negative in for y, you can see that that's going to return back to its normal form. So x equals y squared, right? And so he does, yeah, it's just the opposite of even, right? But the opposite of even is not odd, correct? Does that make sense? Yeah. You think x-axis symmetry is the opposite of y-axis symmetry, but the opposite of even, which is y-axis symmetry, is not odd, right? Odd is origin. Confusing. Okay, so now, I do not want to plug this guy back in. I don't want to plug him in and graph him. So what I'm going to do is I'm going to test for a symmetry. Let's test for Let's test for even real quick. Let's test for y-axis symmetry. Even is y-axis, and what I'm going to do is I'm going to plug negative in for x. And let's see if he returns, all right? So just so you know that this is y, right? So I have y. I'm going to leave the y alone. But I have negative 2, and I'm going to replace the x with negative x. And I'm going to replace this x with negative x. Okay, and let's see what happens to him. So let's go piece by piece. The y is just going to stay y, right? What happens when I take negative x and I take him to the fourth power? That negative to the fourth power is going to return back to positive, right? So this is just going to stay negative 2x to the fourth. Does that make sense? What happens if I take the absolute value of a negative x? It's going to be the same thing as the absolute value of the positive x. So he does have y-axis symmetry. He is an even function. Does that make sense? What happens? Okay, I know what happens if one of them returns back, but the other shoot. I just lost power. Un momento, por favor. I just tripped my cord.
Good one. That's so smart. You could think of it.
I know. I read your brain.
Now you probably broke.
No.
That'd be fun.
He unhooks all the time. He's just very sensitive. He's very sensitive. Looking for a signal. Looking for a signal. Boo. There we go. There he goes. Okay, what happens? What happens if this one return back, but this one wouldn't?
Then it's neither.
Then it's not.
Worse than one.
So if one of them returns and the other one does not, the whole thing has to return. So this is an even function. If part of it returns but the other one does not, then it's not an even function. Got it?
Then what would it be then?
Then it would be nothing. Then it would be nothing. No symmetry. Okay? All right. Shall we check y-axis? Let's check even on this one.
Why would we check even?
And y-axis.
Can we check odd?
You want to check odd? Okay, we'll check odd. We're guessing that it's going to be odd. Let's see. Odd, which is origin symmetry, which is plugging in negative x and negative y. Okay? All right, so this will become negative y. This will become negative x. This will become negative x. Yeah? I'm plugging in the negatives. I probably should put them all in parentheses, right? Okay? So there's that. All right, negative y is just chilling. What if I take negative x to the third power? It stays negative, so I'm going to throw the negative out front, so that's negative 4x to the third, right? Okay? And these two negatives are going to make a positive, so positive x. Does he return back to the original? Not yet.
Divide by -1.
If I divide everything by a negative 1, then he will be y equals 4x cubed minus x. Then he will, in fact, return back to the original, so he is origin symmetry.
Wow.
Or he is odd. He is odd. Okay?
So what happens if only one goes back?
If only one returns, then it's nothing.
No symmetry.
No symmetry. Okay? I'm guessing that's what's going to happen over here. All right, so which one should we check here?
Even.
Let's check even. Okay, even is y-axis symmetry. I have to keep writing that down. And y-axis, you're going to plug a negative in for x. Okay, so the y is just going to chill. I'm plugging a negative in for x. Okay, so this y stays. If you take this negative x and you square it, it becomes positive x, right? Two negatives make a positive, so that will be 2x squared. But then this negative is going to stay negative.
Minus x.
Okay, so will he be the same as the original, even if I divide by a negative? No, so he's not even. Does that mean he has to be odd? Odd is origin. He could be. Let's see. I'm going to plug negative x in for negative and negative, right? So this will be negative y, negative x. Okay? So if I check origin, here we go. If I check origin, this y stays negative. This guy is going to become 2x squared. He turns back positive, and this one is negative. All right, now, is he the same as the original? If I divide by a negative, he will be y equals negative 2x squared plus x. Now, is that the same as the original? Still no. So this is neither. Does that make sense? Yeah, that's kind of tricky.
But like, can't you just do the even and then call it neither? And not do the odd?
Probably.
It's an even.
Because it's an even powered function. But so the reason why it's a neither is because it's even here and it's odd here. So it's even and odd kind of at the same time, right? Weird. Okay, good?
Are we done?
All right, let's stop there. Stop there. You should be able to do everything but piecewise. which is up through 46, I think.
44.
So 44. There you go. You can do those all the way up through those. Okay, there you go. All right, bye, Addison. And is that it? Addison.
Send it to Casey.
I might, actually.